Sometimes when we're asked to work with bearings, we are introduced to parallel line rules as well. So we're going to have a quick recap on our parallel line rules, and because all north lines point to the 0, 0, 0 bearing, that means they are all parallel to one another. So you can see here, this north line and this north line are parallel to each other, the same here and the same here. So that means we can use parallel line rules to help us work out missing angles without needing to measure them. If we look at the first one, we can see that we have the angle on that line and we are looking to find the angle on this line here. When we join those lines together, we make an F-type shape. That means it's a corresponding angle, and corresponding angles are equal, so this means this angle here is also 110 degrees. The next one we're going to look at is the co-interior angles, where we have the angle here. We want to find out the angle that's inside this time, here. That makes a C-type shape, which is called a co-interior angle, which means inside this shape should add up to 180 degrees. So that means we would have 180, take away the 110 that's already there, giving us a 70-degree angle left over for this angle here. The next one we can look at is this end one, where we have the angle here, and this time we're asked to find out the angle that's underneath the north line, okay? So this north line can be extended with a dotted line, and we're looking for this angle here. That means we have a Z-type shape. Z angles are called alternate angles, and they are also equal. So that is 110 degrees in here. Now sometimes we need to go further than the workings out that we've got here, and also consider that we have angles that meet at a point. So this is 360 degrees in total that goes all the way around this shape here. Now we know that this part of the shape is 110 degrees. We should also know that this bit, this section here, that goes from the one side to the other, adds up to 180 degrees. So we have lots and lots of information that we could work with here. Let's have a go at an example. Bearing of B from A is 40 degrees. So I have 40 degrees that is sitting on this north line here to make this 040 degree bearing. How could you find what A from B is without measuring it? So we are looking for our angle that goes from B all the way around to this line here. We have a couple of options to do this question. If we were to use our co-interior angles, we would know that this angle here, including the 040 degrees, should add up to 180 degrees in total. That means we would have 180, take away 40, gives you 140 degrees in here. It should be 360 degrees in total if you go from the north line all the way round back to the north line. So if we know that this angle here is 140 degrees, we can calculate angle B by saying 360 degrees, take away the 140 degrees, gives us a measurement of 220 degrees for the angle of A from B. The other option we have is to consider the work we did with the alternate angle. where we know that the angle that sits here, and if we extend this north line down, dot, 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 the angle inside there, that makes a Z-type shape, which means this angle here is equal to 040 degrees as well. We know angles on a straight line add up to 180 degrees. So we could also say 180 degrees add the 40 degrees gives us 220 degrees. So we have separated this journey out into 180 degrees to that point there and an extra 40 degrees there. Either option you can see will give you exactly the same answer of 220 degrees. Press pause and try the your turn question using either method of solving for the angle of A from B. Okay, so we have the bearing of B from A is 060 degrees, and that can be seen here. We are asked to find the bearing of A from B. That is this angle that goes all the way from B's north line around to this line here. Using our first option of knowing that we have a co-interior angle with this angle in this corner here, we know that there should be 180 degrees inside the co-interior angle in total. There are 60 degrees so far, so I'm going to take away the 60 degrees to leave me with 120 degrees. I have 120 degrees in this corner now. From this north line all the way around back to this north line is 360 degrees. I have used 120 in this section here, therefore I can calculate the remaining angle by saying 360 degrees, take away 120 degrees. That would give me 240 degrees left over for the angle of A from B, or the bearing of A from B. The other option is to consider the alternate angles instead by extending our north line down with a little dashed line and knowing that this part of our line is worth 180 degrees. We now need to work out what this remaining angle is here, where we know the angle here is 60 degrees. We want to find this angle there, and when I join it together, it gives me a Z-type shape. Z-type shapes are alternate angles, meaning that this angle here is that 060 degrees again. Altogether, the angle from the north line all the way around the 180 degrees and the 60 degrees here to this line add up to the 240 degrees that we were looking to find. As you can see, either method will give you exactly the same answer.